let's talk about the problem set. In particular, let's talk about this retrograde motion question that has, like all these really complicated instructions and stuff. If you look at the question, you'll notice it has a lot of instructions. I realize that. I think it's an interesting question. The point of the question is to help you do some thinking by just making some drawings instead of doing something else elaborate. But I realize the instructions are long, so I'm making this little video to make sure that you understand the instructions. However, I really, really strongly recommend that before you watch this video, you go read the instructions. And the reason I'm saying that is that there's some things I'm going to talk about, but there's some other things in the instructions that I'm not going to talk about. And it's really tempting when you've seen a video of something, like, well, I've seen the video, like, why should I read the directions? Like, who wants to read directions? They're long and complicated. And that'll be really tempting, so then you'll go and do the problem, and you'll miss some details. So I really, really recommend that you go read this stuff, all of it. I realize, like, hey, it starts on this page, and here's a question. And then, like, you flip it over, and it's like, oh, here's this crazy diagram. And then you go after that, and it's like, wait, here's this blank sheet of paper, but it says this is the place for your explanation in your table. And then after that, there's one more thing that's like all these technical, complicated, wait, what are all these things? Go look at all 4 of those pages before you watch the rest of this video. And I think then the video will actually be more helpful to you if you do that. So now's a good time to pause your video. No, really, pause the video and go read the directions and then come back. No worries, I can wait. I'll go do something else. Hey, I'm back. You're back. Cool. Now we're ready. You've read the instructions, so we can talk about these things. First, a couple of things about the question itself, just to put everything in context. So I want you to notice pointer thing. I want you to notice that this question is asking you for three things. It is asking you to make a diagram. It's asking you to make a diagram. It's asking you to make a table of information based on your diagram, and it's asking you to write an explanation. So diagram, table, explanation. I'm going to talk about the diagram part. The table and the explanation part are important, but you need to go read the instructions about them. In order to write through this diagram, you're probably going to need to mess around some before you settle on a really good diagram. So here's what I don't want you to do. I don't want you to be like, hey, okay, here's my question, and then, oh, here's the diagram. So now I'm just going to start writing on the diagram. It seems like that's what you ought to do is go start writing on the diagram right away. Hey, how come you're hiding behind? Okay, here's a diagram. So it seems like you ought to want to just start writing on the diagram right away. I would really encourage you not to start writing on the diagram right away. Flip to the end of the packet where there are 2 scrap versions of this diagram for you to experiment with and scribble all over and spill coffee and hot cocoa or whatever on there. So do that first, and then once you have something you really like, then you can come over and reproduce it here. It won't take you very long. Just redraw a nice version of it here. I'm going to draw on this one because it's the only one I have on this whiteboard. But that's funny. You just have to get used to the idea that to point to the thing, I have to point when you this one. Is it really? Does it end up backwards? I'm gonna have to find out. Like when I point now on the screen, it looks like I'm pointing to the diagram, but in fact I'm pointing off the other part of the classroom. I'm gonna draw on this diagram. But before I draw on the diagram, I'm going to go have a look at the instructions. Instructions. Blank. Here are the instructions. Oh, I already wrote in the instructions. Okay. So the technical instructions include 3 important ideas. Idea number 1. If you're looking at something in the sky, like that's just supposed to be some object. Anyway, something in the sky. Like, where is the thing in the sky? And the way that we do that is we look at the thing and then we look past it and see what's going on with the background stars. So look past it. And if this was in the past and you were really familiar with the night sky, you'd be like, oh, what's behind that thing? Oh, what's behind that thing is, the constellation Libra. You'd be like, oh yeah, my my thing in the sky is in Libra. But if you wanted to be more specific, we would talk about like the angle. And by the way, the angle numbers on here, is the angle away from the vernal equinox, but not crucial. But this is what you're going to want to read off. Where are we pointing? So this might be, I don't know, 202 degrees, 203 degrees, something like that. So that's thing 1. What's the position of something in the sky? Thing 2. How do we do this for Mars? Well, in this drawing, we're not talking about a stick figure looking at the sky. We're talking about, somebody who's on Earth. I mean, you could picture a tiny little stick figure. The point is, we're on Earth. We're looking at Mars. You do exactly the same thing. You'd be like, I'm on Earth. I'm looking at Mars. And then you extend that out. Only you don't extend it out in this messy way that I just did on the whiteboard. You use a straight edge. So you get a nice clean line on your paper. I really recommend using good straight edge and a nice well-sharpened pencil to make yourself a nice clean diagram that you can really read easily. So that's how we're going to read off the position of Mars. And then thing 3 is, how do Mars and Earth move? Well, the other diagrams were not to scale, but this diagram is to scale. So if the radius of the Earth's orbit is 1 astronomical unit, the radius of Mars's orbit is 1.5 times that. So in this drawing, we've got 2 circles, and the outer one has a radius that is 1.5 times the radius of the inner one. If you don't believe me, you can measure it. So that's important. Second thing that's really important is how they move. So every 2 weeks, the Earth moves about 15 degrees in its orbit. Right? It'd be like, go from there to there. In the same amount of time, Mars moves 8 degrees in its orbit, from there to there. These are not exact numbers, but they're good enough for our purposes. So what this means, I've put tick marks on the diagram at 15-degree intervals and at 8-degree intervals. So you can start Mars and Earth anywhere you want on the track, but the track helps you to know how to advance them. So like, let's say you're like, oh, I'm going to start Earth here, and I'm going to start Mars here. Then 2 weeks later, Mars would be 1 tick ahead, and Earth is going to be 1 tick ahead. Those are the 3 things. How do we find something in the sky? How do we find Mars in the sky? How do we move the Earth and Mars? So let's go to the big diagram and talk about what this is good for. Remember, I'm doing this on, the nice version of the diagram that's right here, right after the question. You should not start here. You should start at the end of the problem set where you've got scrap ones that you can mess around with, and then once you've settled, you can come back here. So notice the orbits are a lot smaller in this case. This is still not to scale because like how far away are the stars? A long way. So this diagram is not going to give us exact results, but they're going to be good enough to get the idea. So A, you are trying to find retrograde motion so that you can explain what makes it happen. So we don't know where to start Mars and Earth in this picture. So on your scrap paper, you might want to just, I don't know, pick some arbitrary places. It's actually helpful to you if you pick some places that end up not giving you retrograde motion, because then when you want to explain retrograde motion, you can be like, oh, see this here? That's not retrograde motion. This thing over here, that is retrograde motion. And now it's much easier to explain the difference than if you're just like, oh, I found retrograde motion. Well, why? What's the, you want to have something. So I'm just going to pick some things arbitrarily. Like, let's just say, I don't know, Earth is going to be right here, and it's the starting place. So I'm going to label it 0 because it's 0 time is going by. 0. And I'm going to just say, oh, how about Mars is here? I'm also going to label that, right? That's where Mars is on the 0. And then we're just going to be like, oh, where does Mars look in the sky? And then you're going to read off that value, except you're going to do it neater with a sharp pencil and a straight edge. And then you'd be like, you're making a table. So you might make a table somewhere else. Be like, oh, on day 0 or week 0, that's where Mars is at that number. In this case, it's, I don't know, 323. And then you'd be like, oh, after 2 weeks have gone by, you can use whatever numbering scheme you want. So you'd like advance Earth a little bit by 1 tick, advance Mars by 1 tick, and be like, where is Mars? Like, oh, this is after 2 weeks have gone by, 2 weeks have gone by. And you're going to read off some other number. And then you just proceed. Then you look at the table and you go, given this table, has retrograde motion occurred? I'm not going to say yes or no because you need to know what retrograde motion is. You can go read that. So that's the idea. If you make one that doesn't give you retrograde motion, that's good because you can talk about that in your explanation. And then wait till you find one that does give you retrograde motion. What if they start here and then they start here? And then you want to try to explain why the one that does give you retrograde motion gives you retrograde motion and the other one doesn't. Okay, that's the idea. Go forth, do some astronomy. See you all soon.